Okay, welcome guys. Let's take a look at this question. It said, how many isomers are in C5H12? Right? First thing you need to know is that isomers are compounds with same molecular formula but different structural. So anytime you're asked to find the number of isomers present in a compound that contains just carbon and hydrogen, like in this case now, carbon and hydrogen. So basically what you're simply going to do is use this formula 2n minus 4 plus 1, where this n is the number of carbon atoms here. So you simply say 2, 5 minus 4 plus 1. 5 minus 4 is 1, so 2 raised to the power of 1 plus 1. 2 raised to the power of 1 is 2. 2 plus 1 is equals to 3. So that is how we got the answer. So the answer to this question is 3. Alright, we have another question. They said, the functional group in alcohol is dash. First thing first, we need to know what a functional group is. A functional group is an atom or group of atoms that defines the chemical reactivity of a compound. Right? Now, let's liken it to human beings. Right? There are some features you see in a woman, and you know this person is a woman. There are some features you see in a man, and you know this person is a man. Organic compounds also have their identity. The identity is what we call the functional groups. So each organic compound have their different functional groups. So this question is telling us the functional group present in an alcohol is dash. Now the answer to that, alcohol has OH functional group. So the answer to this question is OH. So alcohol has OH functional group. But I'm going to explain this other functional group. So this is actually alcohol. Now the first one is alkanoic acid, which is also known as carboxylic acid. Okay, so this is alkanoic acid, which is also known as carboxylic acid. So anywhere you see COOH, this functional group is an alkanoic acid. We have this. This is alkanal, which is also known as aldehydes. Then we have the last one, which is a ketone. This is alkanone, or a ketone. So the answer to this question is D. Alcohol has OH functional group. All right, we have another question here. The question says, which of the following is an alkyne? Now, it's important for us to know what is an alkynes. Alkynes are hydrocarbons. Remember from question 1, I told us that compound that contains only carbon and hydrogens are hydrocarbons. All right, so hydrocarbons are divided into two. They are aliphatic and they are aromatic. And under the aliphatic, we have the alkanes, which has a formula of Cn, H2n plus 2. We have the alkenes, which has Cn, H2n. And we have the alkynes, we have this. So basically, well, this n, where n is number of carbons. So if you want to answer questions like this, there is no need you doing wasting your time analyzing one of each option one after the other. So this is what you're simply going to do. If you noticed, we have 3 carbons, 2 carbon, 2 carbon, 2 carbon, 2 carbon. All right. So let's check out something. This is alkanes. Alkane is 2 Cn 2 times n. So but before we proceed, the first member of alkene starts from n is equals to or greater than 2. Same thing here. For alkyne, n is always equals or greater than 2. For alkane, n is equals or greater than 1. So if you noticed, alkanes is the only hydrocarbon that can permit 1 carbon atom in its compound. So this is not an alkene. The least member of alkene must have 2 carbons. So this is out, leaving us with 3 options. So if you put N here to be equals to 2, since all of them have 2 carbons, so this becomes C, where you see N, you put 2. 2 times N, where you see N, you put 2. So this is going to be H. 2 times 2 is 4. So this becomes our answer, right? And this answer, this is called 18. As simple as that. Now the question here says, the compound C3CH2NH3 is dash. Now, remember I told us earlier that every organic compound has an identity. The identity is what we call the functional group, right? So anytime they give you a compound like this, what you should be looking out for is the functional group, which is this NH2. Every organic compound must always have carbon and hydrogen. So this is compulsory, but not all organic compound will always have this. This is actually identity of a particular compound. So NH2 is an amine. Amine has a formula of NH2. So I'm just going to write out the formulas, the functional group for all of this so that we'll actually stick to our head. Alkane does not have a functional group. Alcohol has OH as its functional group. Esters has COOR. So anytime you see COOR and you're being asked which compound is that is an ester. Please do not confuse it with COOH. COOH is an alkanoic acid or carboxylic acid, while this is an ester or an alkanoate. So this is an alkanoate or an ester. Okay, we have the next question here. They say, which of the following compound will decolorize bromine water? Which of the following compound will decolorize bromine water? Now, first thing first, you need to understand that bromine water is reddish brown, right? So they are asking us which of these that when it comes in contact with bromine water, the reddish brown will change to colorless. Now, it is important for us to know that it is only compounds that contains a double bond that will decolorize bromine water, unsaturated compounds. Compounds that contains a double bond. And obviously, compounds that contain a double bond, they are always alkanes. Right? So you look out for the compound that ends with ENE. This guy is an alkane because it's ending with ANE. So this will not decolorize bromine water. This is ethanol. Ethanol will not decolorize bromine water. Methane is an alkane. It will not decolorize bromine water. And if you look at this is a double bonded compound, ethene. So this ethene is what is going to decolorize bromine water. Remember, bromine water is reddish brown. So when ethene comes in contact with bromine water, it decolorizes it. So in case you're being asked, which of the compounds, alkanes, alkenes, alkanols, decolorizes bromine water? The answer is alkenes. We have another question here. Please, if you're watching this video, please, and you've not subscribed to our channel, kindly tap on the subscription button. It will encourage us to do more video. And tell us the next topic you'd like us to treat on the comment section. The next question says, which of these can undergo addition reaction? Now, organic chemistry has a lot of reactions. We have addition reaction, we have substitution reaction, we have rearrangement reaction, and so many other reactions in organic chemistry, elimination reaction. But each compound, there are some compounds that undergoes a particular certain type of reaction. Class, any compound that contains a double bond, apart from benzene ring, any compound that contains a double bond can actually undergo addition reaction. And any compound that contains a triple bond. So addition reaction is basically a case where you add an atom across these 2 carbons, and of course you remove one of the bonds. So imagine me now adding something here, I'm going to remove this. You're adding like you're replacing this guy. So compound with double bond and compound with triple bond will undergo addition reaction. And if you look at the options, they said alkynes only. No, alkynes are compounds that contains triple bond. Remember I said it is compound that has triple bond and double bond. So this is not the correct answer. They said alkanes. Alkanes contain single bond, so it will not. Addition reaction is a type of reaction that takes place where there is a double bond or a triple bond, whereby you add across the double bond and reduce the double bond. So if I add across here, if I put H here, for example, I remove this double bond here. So that's a concept in addition reaction. So alkanes do not have a double bond, so there is nothing to remove here, and you cannot remove this bond. Okay? So alkane is not the answer. Alkane, yes, alkane will undergo. And alkynes, of course, a double bond and a triple bond. So this is the answer. And of course, the last one is alkanols. It will not undergo. So I believe it's self-explanatory. If you have any question, please drop it on the comment section. We have another question here that says, which of the following is an aromatic hydrocarbon? Now, hydrocarbons are classified or divided into two. We have the aliphatic and we have the aromatic. The aliphatic hydrocarbon comprise of alkanes. Now, hydrocarbons, we have aliphatic and we have aromatic. Now, under the aliphatic, we have alkane, and under the aliphatic, we have alkenes, we have the alkynes. And under this guy, we have benzene. So, if you look at this option, how will I know that a compound is an aliphatic? Class, anytime a compound ends with kene, like it ends with ene, and it's not benzene. Anytime a compound ends with ene and is not benzene, automatically that is aliphatic. Anytime a compound ends with yne, alkynes, is an aliphatic. Anytime a compound ends with ane, is an aliphatic. So if you look at this option, 18 is not an aliphatic, is not aromatic, it's aliphatic. Ethane, aliphatic. Methane, aliphatic. That leaves us with benzene, which is the answer. Okay. We have another question here. Which of the following is a reducing sugar? Now, this is under carbohydrates. You may want to ask yourself, what do they mean by reducing sugar? So cut the long story short, right? Class, all monosaccharides are reducing sugars. All monosaccharides are reducing sugars, right? Now, if you look at the option, starch is not a monosaccharide. Starch is a polysaccharide. Saccharide is sugar, right? So when they say monosaccharide means one sugar unit. Starch comprises of so many sugar units. So the answer is not starch because starch is a polysaccharide. All reducing sugars are monosaccharides. So this is not the answer. Cellulose is also not the answer because cellulose is actually a polysaccharide, just like starch. Now, not just all monosaccharides are reducing sugars, right? Most disaccharides are also reducing sugars. The disaccharide that is not a reducing sugar is sucrose, right? Apart from sucrose, every other disaccharide at this level, they are all reducing sugars. So the answer to this question is not protein because protein is not a sugar, right? Protein is not a sugar. So the answer to that question is maltose. Maltose is a disaccharide because it comprises of two sugar units. And in case you're wondering, how many sugar, what and what makes up maltose? Maltose is a disaccharide that contains two glucose units. So note this, all monosaccharides, glucose, galactose, they are monosaccharides. They are all reducing sugars. Maltose is also reducing sugar because it contains two glucose units. Now the next question says, Which of the following is a primary amines? If you could recall, earlier I told us that the functional group for amines is NH2. But as you're moving from option A to B, the H is reducing. That means we are replacing this H with R. So basically, class, primary amines are basically a case where this nitrogen is having two hydrogens. So this is a primary amine. I'll use degree 1. When this, it means there's meant to be hydrogen here. When this nitrogen is having one hydrogen, like in this case now, that is a secondary amine. When this nitrogen is having no hydrogen, that is a tertiary amine. Right, this is quaternary, which they don't, I think in your syllabus is way above the scheme. So primary amines are amines in which the nitrogen, the N, is having 2H, which is this. So this is the correct answer to that question. This is not the answer, and this is not the answer. Now, question 3 says, which of the following is a secondary alcohol? Now, secondary alcohol, how do we know? Alcohol can be classified into primary, secondary, or tertiary. How do we know when an alcohol is primary? How do we know when it is secondary? And how do we know when it is tertiary? Now, look at the carbon bearing the OH. Now, let's asterisk the carbon. Class, if the carbon bearing the OH has two hydrogens attached to it, it will be a primary alcohol. If it has one hydrogen attached to it, secondary alcohol. If it has no hydrogen attached to it, tertiary. Right? There is no room for the carbon having three hydrogens. So this is neither primary, secondary, nor tertiary, because the carbon bearing the OH is having three hydrogens. This doesn't fall anywhere under the classifications of alcohols. However, if you look at this, the carbon bearing the OH, which is this one with asterisks, is having two hydrogens. So these are primary alcohols. The carbon bearing the OH, which is this, is having one hydrogen. This is a secondary alcohol. The carbon bearing the OH is having no hydrogen. This is a tertiary alcohol, degree 3, secondary, and primary. Alright, so if you enjoyed this past question class, do well to subscribe and tell us the next topic you would like us to make video on. Alright, my name is Delzi, by the way. Please share the video to your friends.